Operation pneumatic actuator using a locking unit controlled with Staccato FPU positioning unit. On the actuator, a 63 bore actuator, I have a position feedback sensor mounted. I have a lock mounted on the actuator and also a 3-2 normally closed valve and some loads. This will be controlled using Staccato's FPU positioning unit, allowing an pneumatic actuator to go to any desired position. The FPU unit needs a power supply, 24 volts. It has 2 analog input control signals, either voltage or current. And this port is the feedback cable from the position sensor. Any position sensor using 4 to 20 milliamp feedback will work together with the FPU unit. Air supply works almost like a 5-2 valve. Air supply and supply to the actuator exhaust. If we look at the input, I will today be using the 4 to 20 milliamp control signal using this control box. I will also use the digital inputs, and the digital inputs are located at this port. This is a M12 12-pin connector. At this port you will have access to all the digital inputs and outputs. 3 input, 3 outputs. Also to IO-Link and to the PC software. So to access all this at the same time, I'm using a control box, obviously optional, it's not required. But in this case I'm using a control box. I have all the wiring for the FPU connected on this side, and on this side I have my digital in and outputs. I will be using all 3 digital inputs, 1, 2, 3, the white cables, and I'll be using 1 digital output from the FPU that's connected here to this cable, and that cable controls the 3-2 normally closed valve. So the FPU unit is controlling that valve. I have some power supply just to operate the digital inputs in this box. And on this side I have the connection to the PC software for parameter setting. This is also possible using IO-Link. Put on the lid, and as I'm using 3 digital inputs, that gives me up to 8 different actions to choose between. If we take a look at that, in the software we're using preset position input. The 3 digital inputs allows 8 different operations, and in this case I'm going to use 6 of them to control a position, to go between positions. The 7th option I'm going to have for closed valves, and the final I will exhaust the actuator. So this is just controlling the actuator using digital inputs. If we look at the basics, I have fitted in this case a sensor that's 503 millimeters long on the actuator, so that's what I print in there. I have a 63 bore actuator, so here you choose the size of actuator you're using. And then you have the operation mode. We will be using preset input and also (4 to 20 milliamps). Next level is regulator setting. That's the P value, how aggressive you want it to be. Speed and accuracy. You can use accuracies from 0.01 upwards depending on load size, what FPU size you have, and so on. To control the 3-2 valve that's operating the pneumatic brake, I'm using the digital outputs. In this case, I connected the digital output 1 for this operation, so I choose that. You can choose the 3, but in this case I'm using digital output 1. I want that to be activated when position set point is achieved. You can choose for the 3 digital outputs what you want to use them for, but in this case I want position set point achieved. It's possible to set a response time for that signal. In this case it's not required. I want the signal to be off when it's in position. Because I'm using a normally closed valve, I want to cut air supply and the lock will lock. When it's moving, it goes high, so the actuator can move. So, that's the basic settings. Let's operate this. We're gonna start operation using the preset digital input. I have 6 different positions, and then I have a locked valve position and an exhausted position. So let's operate. Small movements. Larger movements. In this position, I have locked the valves, so I can go and exhaust the lifting chamber. We cannot move, the lock is obviously working. We can exhaust the actuator completely, locked in both directions. If I move back to the same position now, you hear the FPU start working. That's because I set a minimum pressure, in this case 150 kilopascal, so the actuator will be pressurized. This to avoid a very sudden movement when we start moving it again. I move to analog control, 4 to 20 milliamps. So that's how our FPU unit can control an actuator using a brake. In this case, the brake is ISO certified for safe applications. So we can and our FPU unit is using normally closed valves. So we can basically achieve performance level D, category 4 systems, even PLE. The redundancy we have is closed valves in the actuator and lock. And then depending on how much monitoring you will use, you can achieve performance level E or performance level D. We can monitor the lock. We have constant monitoring of the actuator position and so on. So that's how it works. Thank you.